Go.
All right. So hello, everybody. My name is Mark Kaplan. I'm going to be presenting about data analytics in baseball and the effectiveness of shifting in Major League Baseball. And I'm going to explain all these terms throughout the presentation. So it should be pretty not too long, not too complicated, either on the math side or on the baseball side. We'll get through all this stuff. But this is me, Mark Kaplan. Right now, I'm pursuing a master's in data analytics and visualization in Yeshiva University. I worked with Lev over the summer in Redepth, which I had a really nice time. Thank you for him for that. And this is my last semester, so I'm going to be graduating in January. So just a little, I'm going to give a little background of the history of data analytics in baseball. It's a very interesting story. Books and movies have been written about it. And then I'm going to give a little, just a 1-minute intro into just the one basic rule of baseball. And then what I focused on in my research. I did for a class in a research class in my master's program in grad school. So to begin with, right, basically, baseball is huge, right? I mean, it's in 2021, which is considered a down year because of COVID. The combined revenue of all the Major League Baseball teams was about $9.5 billion. So, and each team obviously looks for as many competitive advantages as possible, right? They want to win more games. They want to win more championship every year. They want to get into the playoffs, right? Any edge, any competitive advantage that they could use, they want, right? That'll bring in more money, more wins, more fans, more merchandise sales. I mean, it's a huge, other than the game itself, which people, you want to win, there's so much money behind it. And the story behind modern baseball strategy, it's very interesting. It's largely data driven. And in the past, tactics have been employed based on tradition or feel. I feel like the executives were like, I feel this player looks like a good player. I think this guy has a good build. I think he has a nice, beautiful swing. He throws the ball well. But there was no actual data-driven analysis. There was no hard data. There was nothing backing it up. And a lot of it was based on tradition and feel. And they used some statistics, but those statistics weren't based on anything real. They were just statistics that people looked at and they thought was a particularly good statistic, but there was never any studies, there was never any background. And the move from this kind of tradition field-based tactics and strategy occurred in the late 1990s. And that's what's called the sabermetric. That's kind of the term for the statistics within baseball, or the Moneyball revolution. So what was the story? I'm just going to give a quick background of the story. This is some key figures in the statistical revolution. So in really in the 70s and 80s, this guy all the way on the right, who really had no official training in statistics, and that was kind of the beauty of it, that he thought in a very simple way. His name is Bill James. He has a degree in economics and teaching. He obviously knows statistics and probability, but he wasn't thinking advanced. He was kind of thinking first principles. What really statistics correlate with wins? What kind of players correlate with wins? A very basics first principles. That's kind of the beauty of it. Strategy based on a data-driven analysis of baseball. And he was writing this. He wasn't really getting now he's the biggest name in baseball. But back then in the 70s and 80s and 90s, he really wasn't getting a lot of traction. It was, no one really paid attention to him. So in the 90s, there was this guy called Billy Beane. He was an executive for the Oakland Athletics. They're a team that plays in California. And the interesting thing is they were a poor team, right? They couldn't afford the big players. So they were looking for a competitive advantage. How do we target players that are good, that other people are overlooking? We don't have money. We can't get the big name players, but how do we find players that other people are overlooking and we can win? So Bill Beane, who was the executive of this team, kind of read Bill James' work, implemented Bill James' work, and he was extremely successful. And basically, everybody now uses this kind of thinking, even the rich teams. So the rich teams have that advantage back. And there was a famous book written about it called Moneyball by Michael Lewis, and there was a famous movie with starring Brad Pitt and Jonah Hill. So that's basically there's a lot more to get into. There's websites and books and papers and things about how statistics is used in baseball, but I'm not, going to get too much into that. But the story is very interesting, and the movies, and the movie and the book I highly recommend. So baseball, what's the background on my research? So just really not getting into too much details about the rules, but throughout the past decades, baseball teams generally position their defensive. This is all the defenders, right? The batter is not pictured, but he stands right here. They position their defenders in this kind of positioning where they're all equidistant from another. Right? It doesn't make a difference, the names, just the positions. That's the most important thing. We're looking at their position, which makes sense logically, right? You want them as all equidistant as possible to cover as much ground as possible, right? And this is called straight up. However, one of the parts of the statistical revolution in baseball, which only happened this past maybe 10 years, right? Those it started in the 90s, but this kind of next step only happened in the past 10 years. Very interesting was the use of modern tracking technology, radar and video, where they track everything. Everything is tracked: the player's movements, the ball movements, a player's bat movement, a player's certain for certain things, at about 1 to 2 terabytes per game. And there's 160 games for times, well, there's 32 teams, so times, I guess, what is it, 16 times 16, so 162 times 16 games, and that's how many terabytes there are per game, and 1 terabyte per game. So it's a lot of information. And what this led to is they're moving away from a more traditional defensive position to more granular positioning based on the offensive profile of each batter. And that's, all of these positionings are collectively known as the shift. And I'm going to show you a clear example, right? Here we saw everybody was equidistant, right? This was the traditional way of doing it for the past 150 years since baseball was started. Now they're going a lot very different. They're shifting everybody to one side. So what you can see here is a very interesting thing. You can see the overlay, which we have through this new technology of, this is the batter right here. We see he hits the ball, right? This is his layout of his hits, right? He hits most of the things, or most of his hits are to the right side. So clearly, I mean, well, let's just shift everybody to the right. And that's exactly what they're doing, right? That's exactly what they're doing here. They're pushing everybody to the right side. And here's an even more extreme example. Yeah.
I have a question, Mark. Do they notice a switch from the other direction if they're left-handed or something?
Right. Oh, so that's a very good question. I'm not going to get into that because there's a big difference. This is a left-handed, and left-handers they hit to the right. And they're known much more, for whatever reason, to be a lot more one-sided, a lot more right-handers, which would hit to the left side, where this guy 10%, they would be more. They're a lot really more equidistant. There's something about lefties and how they swing that they hit a lot more to one side. And my study was just focused on left-handers. I didn't look at right-handers at all. So that's okay. Yeah, I just didn't look at them. Yeah, because they hit differently in their position against. But yes, you would see in the extreme cases people switched all the way to the other side. Yeah. So in the extreme, but there's a lot less extreme cases, basically. That's the answer. There are some extreme, but a lot less. So here's another extreme where you have no one on this side at all. No one positioned here, right? No one positioned here. Everyone switched to the right because they're expecting this guy, based on the tracking, to hit the ball. So I'm just going to show 2 quick videos right here. This is just some of the Python code I'm going to go through later. Here's a traditional hit. It's just, the pitcher right here has the ball. He's going to throw it to the hitter, and the hitter hits it, and he's safe. He hits it up the middle. No one gets it. No one can make any play. Standard positioning. Kind of hard to see the ball, but he's safe. Here's just this happened last night. A beautiful play where they're also positioned straight up. The pitcher has it. He throws the ball. The hitter hits it on the ground. Right. Position straight up, and this player makes a beautiful play, but there's nothing particularly remarkable about the positioning, just about the range of the player. So that's and then he's out. Here is a perfect example of the shift. I'm just going to show this here, of a perfect example of how the shift works, where everybody's pushed to the right side, and one player's in perfect position to make it, and he's out. Right. So that's the extent of the rules that we need to know. That that if he gets to the base, if the batter runner gets to the base before the ball, he's safe, versus here they made a play and he's out, right? That's the extent of the rules, if that makes sense. And the point is that everyone's shifted to the right side, and someone was in position. So my question was very simple. How effective was this? Right? How this really started in 2015 when this tracking system came into place, 2016 through 2019. So those are the statistics that I looked at from 2016 to 2019. How effective was this shift right? How effective was positioning all the players to the right side in this extreme positioning. So the statistic that I looked at was BABIP. It's a fancy it's batting average of balls in play. All it's saying is how successful were the batters when they swung, when they hit it, how successful did they, how many outs did they make, how many times were they safe. The average is about 250, 260, meaning 25%, right? 25%, 26%. A really good person, a really good hitter would be successful 30%. A horrible hitter would be under 20%, right? So, and yeah.
Sorry, I have a lot of questions.
Yeah. No.
This is very interesting. Does is it based on just hitting it or hitting it and making it to a base?
Right, it's hitting it and making it to a base. Yeah.
Okay, that's what I thought.
Yeah. Sorry. Yeah, sorry. It is a little confusing. Yeah, I'm. That's why I tried to just to go over it. But yeah, I totally, yeah. So, and there's other statistics. So that's the main statistic that we looked at. So here's one interesting thing on the left, just to focus on the left. So on the left, we see is the blue is the infield shift versus the orange is the traditional standard alignment, right? And you see it increased every year. The blue has been increasing every year. And really the 2018, 2019, there's a big jump. So a lot of teams are moving to this positioning, right? Once one team does it, other teams do it, other teams do it. And hopefully it was effective. Hopefully. So that's just a proof of concept that they did move to that, right? And therefore it is something significant to look at. So here is the main one of the main things that we looked at. So what this chart is showing is the size of the dot is the same thing as what this left chart is showing, that the total amount of percentages that it's shifting. So we have it right over the years. It got a little smaller here, but it got larger basically every single year up to 30%. And that's the years, right? 2016 through 2020. And this is what the BABIP, the batting average of balls in play, the success of the batters, right? So the lower the success rate is, the better for the defense, the better for the positioning, and the worse for the batter, right? So this means 250 or 0.250 means the batter is successful 25% of the time. And that's about, that would be considered actually pretty good. And every year the average changes, but this is the overall success rate of the batters. And what we see just from a simple look is that there is some kind of relationship, right? As there's more shifts, as this strategy is used, the defense is better, the defense is more effective, and the batters are less effective. So that's that I guess that's one way of answering it. Another way of looking at it is on here. So I just did two kind of machine learning algorithms, very simple, a linear regression and a decision tree. How does infield alignment affect hit probability? So there are algorithms that affect how that can output how successful is the batter, right? There are based on how fast he is, where he hit the ball, a lot of different features. Not a lot, maybe like 5-6 features. So I looked at those features with or without shift data. So it's just a indicator. Is a shift present or is not a shift present? In that's on the right, and on the left is there was that indicator was not there. Excuse me, I made a mistake. I'm sorry about that. It's the opposite. On the left, the indicator is there, and on the right, the indicator is not there. So the accuracy and precision of when that indicator was there were a little higher in the linear regression. Actually, precision was significantly higher in the 0.55 instead of 0.42, and the accuracy was a little higher, 0.76 versus 0.73, and the decision tree, interestingly, was the same, which might just show that it was good already and that indicator didn't really affect anything. So that this was another way of looking at it. A final way of looking at it, I'm not going to go through the particular statistics, but red is bad for the defense and green is good for the defense. And these are all just different statistics of whether the shift was in play, whether the shift was used or whether the shift was not used. That's the second line. And what this shows is there are secondary effects, right? There are other ways the batter could be successful without hitting the ball. And did this strategy have any secondary effects? And as we can see, it did have secondary effects, some of them positive and some of them negative. And the complicated thing is there's no one overall number that says it was good or it wasn't good. In some areas, it was good. In some areas it was good, and in some areas it really didn't make much of an effect. In some areas it actually was negative. So that's kind of the next step is kind of trying to figure out all how it all affects, how it kind of it all blends into one. So just to sum up the conclusions. So the statistical revolution in baseball really happened in the 90s, where they were moving away from tradition and from whatever beliefs they had about how batters worked or how pitchers worked or how strategies worked, to relying data driven. And particularly in the past 10 years, when we have radio and when we have video and radar technology in how to position. So in the main answer is that yes, it was effective in what it's mainly trying to reduce, which is the batter hitting the ball and getting on base in that way. But there were some other side effects which may have been positive, may have been negative. They're more kind of nuanced ways of looking at the batter production and the batter effect. Just some additional things like which I mentioned are all, as you asked, looking at the other side, the righties. I just looked at lefties. How would this affect righties? That's a whole nother question. Also, the funny thing is that they're looking into banning this because it's so effective in reducing lefties, at least hitting the ball and getting on base. They're looking at banning this. They say, you can't do this anymore. You have to be in this traditional lineup. They're looking at banning this defensive alignment. But as of now, it's not banned, at least not completely banned. So yeah, that's the end of it. I apologize again because baseball is a little bit of a complicated sport, but I think hopefully the main points of the research and the main question was asked and answered, and hopefully it was understood. And yeah, that's it for me.
That was really interesting. I liked it. It's actually, I have a funny story. My dad and I went to a Diamondbacks game when I was in Arizona, and and my dad was analyzing if we caught a ball, like a foul ball.
Yeah.
And he goes, "Oh, he's gonna have to be left-handed. He's gonna have to do this." And
oh, where to sit?
And then it happened.
Oh, nice.
And hit my dad. He didn't have a glove, and he was like, "I don't have a glove with me," and like all this stuff. But it hit him in the chest, and then it hit his arm, and then it fell in front of him, and no one was there, but he grabbed it. And then he's like, "Oh, I'll give it to some kid." And I go, "I'm your kid, give it to me." So anyway, I thought that was funny, but that's an interesting, that's interesting that they figured that out with the movement over to the right side.
Yeah. And just the main point, like every team is looking for a competitive advantage. So any analysis that they can prove that this was helpful or that was helpful, this is very, very all the front offices and the executives, this is exactly what they're hiring these teams of data analysts and machine learning experts, trying to see how these strategies work out and how these can we get a competitive advantage in this one thing to get us another win or another 2 wins or another 3 wins, right? And that leads to more merchandise sales, obviously, and more tickets, and there's a lot of money at stake, and also the game itself, people want to win. So yeah, that kind of was that's the
I thought you were just going to show us the Moneyball movie.
Oh yeah, well
I'm just kidding. No, that was a good movie though.
Yeah.
Mark, thank you, very good. Any more questions? No, then I'll stop recording.